pending. There we go. Okay.
Okay. And today's general body meeting is Circularity and Plastic Waste with Dr. McKenzie. Dr. McKenzie serves as an assistant professor in the University of Akron School of Polymer Science and Engineering. He's also our faculty advisor, and he has done a fantastic job. He earned his PhD in chemical engineering in 2013 from NYU Tandon School of Engineering, and that's where he also did his undergraduate, and he obtained his master's from Columbia University. So without any further ado, Dr. McKenzie, feel free to take it away. I'll stop sharing my screen. And I'm really excited to hear about circularity and plastic waste today.
Thank you so much, Michaela. Again, my disclaimer, so those of you who saw me speaking earlier, I fully apologize. This was my shameless attempt at trying to kill two birds with one stone. But luckily, I didn't get through all my slides earlier today, so hopefully I get through them today. So let me start sharing my screen. Let's see, not that screen, not this screen, that screen. There we go. Okay, so this is formally my third lecture to the ESW general body, and I thank you all for having me be a fixture in your meetings. I'm actually proud to be your advisor. Again, I think you guys do great work, and really my job is to give you the best opportunities to shine. So the first time I gave a talk to you guys, I kind of spoke about how my research connects with sustainability. My second talk was giving a different perspective on what sustainability means. And today, I'm going to try to give a deeper dive into just the notion of sustainability, especially as it deals with materials and the environment. So if you're not at all familiar with what I actually do as my day job here on campus, besides teaching, I do a lot of materials research. So I'm a part of the School of Polymer Science and Polymer Engineering. And really, I'm just like a kid in a candy store. I love playing with polymers. I love finding new ways of applying polymers to, in different ways. And my research thrusts are in soft matter dynamics, where essentially I probe how fast molecules move under different conditions. And that's very relevant for processing of materials. I also try to develop new complex structures, or what I call enabling complex structures, using a range of technologies. So in this example here on the left, these are actually confined liquid crystals in a shell of nanoparticles. So that's why you can see the liquid crystals lighting up like individual disco lights. Here, these are fibrillar nanoparticles that we made in a very straightforward process. And these nanoparticles can actually be used as curing agents for adhesives and also filler particles as well. So it has a dual role. And over here, I'm trying to develop multifunctional materials, essentially giving materials more than one function. Normally, when we develop materials, we only care about the mechanical characteristics. But something that I've learned was that we need to find other ways of incentivizing materials, especially on the recycling side. So we're trying to develop polymers that have inherent piezoelectric and optical properties that might be useful in a variety of industries. And on this example here, that kind of looks like a polymer film kind of going crazy. This is actually a polymer film that's exposed to what we call a microclimate. If you don't know much about what a microclimate is, plants, small animals are often exposed to microclimates. So it's just a sharp gradient in environmental properties or features. So you can think like temperature, humidity, and things of that sort. And here, this is just a regular polymer film exposed to a microclimate of humidity. And what we demonstrated was that we can actually generate motion in this polymer by just controlling that microclimate. Some toys that we play around with in my lab. So we do a lot of rheology, where if you don't know much about rheology, I kind of just say, you know, we're punching this material. essentially mechanically deforming it. And then we also do dielectric spectroscopy, where we expose a material to electric fields to understand how electric fields impact materials. And if you're ever interested in seeing where I play, we're in the Olson Research Center, room 101B. So like I said last time when actually the first time when I spoke to your group, I essentially tried to discuss how my research ties into the notion of sustainability. Hopefully I did an okay job in at least showing how sustainability can be viewed in a variety of ways. And if you haven't recognized so far, I like to talk about sustainability from a variety of approaches. So today we're going to just really dive into what is sustainability. The more you talk with me, the more you'll probably see me cringe every time I hear the word sustainability, even though you guys are the engineers for a sustainable world. The reason I cringe whenever I hear the term sustainability is that sustainability is a very broad term. And hopefully I've convinced you of that so far from the variety of presentations that I've given. But when we talk about sustainability in a modern sense, or what I call in a popular culture sense, what we're often talking about is something very focused, right? But usually it's somewhat challenging to describe. So the first thing I want to lead off with is that it's a very ambiguous term, right? And we can use it to describe a range of things, right? But what I kind of like to use sustainability in terms of definition or in an etymological sense is that it's really, we're just trying to sustain something, right? We're trying to preserve something. So I kind of see sustainability as a values-based system, right? The things that we value, we try to hold on to, right? We try to keep, we try to preserve it. But then when we talk about values-based systems from a human perspective, right? We value different things, right? We want to sustain different things. So really, what are we talking about when it comes to sustainability in this sense? So the first thing I think is resource management, right? As a global body, we recognize that resources are finite and we have to do our best to manage these resources, right? So in terms of resources, we have what I call the extractive resources, right? So we have the oil wells or the oil fields that we pump oil out of. And then we have mining, and I'll just say mining as a very broad term, right? Where we essentially try to extract a range of minerals and ores for a variety of things, right? Not just for medicinal purposes, but for electronics, for materials, for really almost everything, right? So we have these extractive processes. And then we have these other resources, right? So we have food, that's a resource as well to kind of help sustain us in terms of nourishment. But there's also been a lot of work that essentially discusses or even utilizes food as a resource in terms of energy and materials. And that comes with a range of ethical questions as well when it comes to food security and issues in food security, especially in populations that already have food insecurity, right? You're going to ask them to essentially use their corn for something else other than eating. You know, that's usually a big ask. And then we have the forest, right? Which is probably one of the first resources that we tended to utilize as a species that we continue to utilize. But you know, we've kind of seen some of the dire consequences of overforesting or deforestation. So when we talk about sustainability in this global sense, right, the first thing we have to understand is, okay, we're talking about resource management. How do we manage our resources? But then the next notion is waste management, right? What do we do with these resources once they have been consumed? And that's where I think a lot of the more popular forms of sustainability have been emergent lately, especially in the area of polymers, right? And rightfully so, right? When we see polymer waste, we get this really averse reaction to it because, in all honesty, as humans, we don't like looking at garbage, right? Something about waste that just completely drives us, you know, cuckoo bananas. So when we see images like this, we have a natural reaction that, oh, geez, that something must be done, right? But if we look at all these other forms of waste management, right, you know, looking at the impacts of deforestation, some of the impacts of industrial processing, right? We essentially emit particulate matter, gases into the air. Notice I haven't yet to bring up water because that completely brings us into another rabbit hole. But managing our resources and managing the waste or the refuse of these resources is especially important. This is an example that I think oftentimes doesn't get talked about. In fact, nobody talks about this form of waste. But this form of waste, I would probably argue, is more dangerous or most dangerous of these examples, and probably most impactful as well. So this is actually waste from coal mines. I shouldn't say coal mines, but from mining. So these are called impoundments, and they're oftentimes hidden in in locations that if you're not looking for it, you will definitely never see it. In fact, I have another image of the same location that shows that it's actually hiding in plain sight, and usually they are. And if you're ever curious about what I call impoundments, then you'll understand really precisely just some of the ramifications of those. But really, one of the big things that I've noticed just so far in my life and in my work is that people often take waste disposal for granted. And one thing I often do to kind of see or to test people's levels of understanding is that just ask a very simple question: where does your garbage go? Do you know where your garbage goes? Usually people don't. And then you can, dial back the question a bit. You can say, okay, what happens when you flush your toilet? Where does that waste go? And usually, you have a better sense of where that ends up. But, for general municipal waste, I would say the average person has no idea what happens to their waste after it leaves their property. And that's, I would say, is an underlying issue, because if we're not conscious of what happens to our waste, then it's really challenging to kind of develop any solutions to waste problems, right? And then, just to kind of help save time, there's also systems management, right? When we talk about sustainability, how do we sustain systems for producing these materials of interest? And oftentimes what we kind of come across is the what I call the my cake and eat it too complex, right? We know that we can't have our cake and eat it too, but oftentimes we really do try to do that in terms of resource and waste management, right? But what oftentimes happens, like this cartoon says, is that we acknowledge that we can't have our cake and eat it too. So what we revert to is we start eating other people's cake, right? We start depleting other people's resources or utilizing their space for managing our waste, right? So concepts that have been emergent in maybe the past few decades, but to a chemical engineer, this is something that we practice day in and day out, is essentially what we call eco-balances, or just having a material balance of our resources, an energy balance of our resources. So we understand just what goes into these systems in terms of resources and what comes out of these systems in terms of waste. Ideally, we should have no waste coming out, and that's what we're going to talk about are just some of these approaches for minimizing waste. But if you notice, this gives us at least a global picture of this system of interest, right? How this system is a part of this environment and what some of these repercussions and ramifications are. But given that, right, I still really haven't pointed out to a problem per se, right? I haven't put my finger and say, look, this is the problem. And that's usually where the challenge is, right? What is the elephant in that room, right? It's always easy to point at the elephant and say, look, there's an elephant in the room. That's the problem. But for a problem that deals in the area of sustainability, because of the terminology of sustainability, it's usually harder to specifically say what the problem is, right? But for me as an engineer, I can't move forward without knowing what the problem is, right? I need to define the problem, so at least I can, work towards a tangible solution. So one of the first problems is that, hopefully you all are aware of this by now, but we are essentially in the midst of an energy and resource crisis, and I cannot sugarcoat that in any way. If you've been keeping up with the news, I would say within the last year, right? Some parts of the world is always dealing with some strain of their resource or some strain of their energy capacity. And the more we try to modernize, the more our population increases, is the more stress that we're going to be putting on these resources, the more stress that we're going to be putting on our energy capacity. So what we have to try to figure out or try to develop are systems that can be more energy and resource efficient, right? And to an engineer, oh geez, efficiency, that's what we kind of strive towards, right? We want to know where our baseline is so we know what we need to improve. So we have to try to figure out, try to find new resources, try to capitalize on renewable resources. And something that I'm incredibly fascinated by, and I actually had this picture up last year, is heat, right? Heat is a very good example, right? Heat is very pervasive. Almost every industry known to us generates heat, but there's not much that we do about heat. Right. Oftentimes heat gets wasted to the environment. It's a potential contributor to greenhouse effects. And really, climate change is the focus of the day, right? We've, at least as a planetary body, most of us have accepted that our climate is getting to a point of detriment to us all. And, looking at some of these challenges is what we need to do, especially in terms of energy and resources. The second problem, when it comes to materials, they come in all shapes and sizes, right? There's materials for different applications, there's materials that have different properties, and we use them in a variety of different ways. In fact, some products are even made from multiple materials. And when we think about recycling, this goes counter to recycling, because recycling actually becomes more cost effective if products are made from single materials with minimum additives, right? So how do we reconcile those differences, right? How do we challenge ourselves into making processes or products more amenable to recycling, right? Especially if we all can agree that recycling is a way or an avenue for us to become more sustainable. But then the challenge with recycling, which brings me to the third problem, is that in reality, there is very little economic incentive for recycling. In fact, I believe it was sometime last year, maybe a year and a half ago. I'm somewhat still stuck in 2020, so my concept of time is not the best. But fairly recently, Ohio stopped recycling glass bottles. Well, I shouldn't say Ohio. This region of Ohio stopped recycling glass bottles. And I was completely floored by that, because of all materials besides metals, I would say glass is probably one of the easiest things to recycle, and there's already an industry for that. So why did we stop recycling? Long story short, it is not economically viable for recycling certain materials or certain types of materials. And that's, I would say that is very unfortunate, because the reality is it's usually more expensive to recycle a material than to actually make new stuff from fresh material, right, from virgin stuff. So what I think is that, we need to create incentives for recycling through these materials themselves. Because, what will happen if we don't try to figure this out is, all these recycling centers, right, we'll just start stockpiling our material, right? And what will end up happening, as we've seen, is that eventually they end up leaking into the environment, right? So for those of us who was just completely floored by the fact that we were actually exporting our garbage to other countries so that they could stockpile it in their warehouses, that's just the reality of where we are in terms of certain forms of waste management, right? So then when it comes to polymers, right, what we have to try to decipher is that, are they friends or foe, right? Me, I'm a member of the polymers community, so I will always advocate for polymers, albeit in a very realistic sense, right? I'm not going to go blind and say they're great in a variety. Excuse me, that they're that they're great in everything and not bad for certain things. But we all have to agree that the polymers industry helped to usher in an aspect of modernity and what I call quality of life that we all more or less take for granted. In fact, something that I've always challenged people on is if you look around the room, right? Tell me something that doesn't have a polymer in it. And usually it's, it's something like, oh, the legs of my table are made from metal, right? But almost everything else in that room is made from a polymer. And this image here is a really great juxtaposition of the problem when it comes to plastics waste, right? So here we have this wonderful activist who was standing in the middle of a plastics waste site, trying to bring awareness to this plastics waste issue, essentially kind of telling us, oh, look, we have to do something about this plastic waste issue. We have too much plastics in the world. Plastics are bad. But then not accounting for the fact that if you notice, right, this wonderful surfboard here, that's made from plastic. The clothing that she has on, that's from plastic, right? So we have to reconcile this, right? We have to understand that polymers, we rely heavily on polymers, right? But at the same time, we've taken a lot of aspects of the waste issue of polymers for granted. And now, to our detriment, we have this continuously accumulating waste that we have to deal with. So just in terms of statistics, so we can start putting this into perspective, when we start looking at plastics consumption, about 60%, so if we add this 40% here and this 19% here, right? So about 60% of plastics go direct to consumer, right? So that's packaging and household items. And the reason I say packaging is that, whenever you buy something, 99 times out of 100, right, I'm sure it's wrapped in plastic, right? We recognize that plastics are good as barrier materials for preserving the lifetimes of materials and for protecting it against the environment, right? But if we then, look at all these other small pieces of the pie, what we realize is that, most consumption of plastics goes through us as a consumer. So what that should tell us is that we have a lot more control over, our consumption of plastics than we recognize, right? But we also have to also reconcile with the fact that we are becoming increasingly reliant on plastics as a commodity itself. So, right, recycling is the answer, right? So that's always the knee-jerk reaction that we should recycle, right? Recycling is best. But without going into any of the numbers, what I will just say as a quick summary is that recycling is not as straightforward as it may seem. So if we use this picture as an example, what we see here is these two really astute, serious workers doing their best to sort through this plastic waste for recycling purposes. What should really stand out is I see 1, 2, 3, 4 bins here, meaning that they're probably trying to sort out 4 types of plastics, maybe. But then what happens to the rest of it, right? And that is usually where one of the challenges in recycling really comes up. Well, in certain instances, we just don't have the infrastructure for recycling, or to put it in a more positive light, there isn't the necessary investment in creating that infrastructure to recycle a broader range of materials. So another answer is, well, what we should then do is design materials thinking about its end of life. Previous to that train of thought was that people would actually design products just for use, right? I'm gonna make a cup so you can drink out of it. I don't care what you do with the cup after you're done drinking out of it. But the thought now is, well, I'm going to make a cup so you can drink out of it, but I'm going to design this cup so that when you're done drinking out of it, it can degrade or it can be easily recycled. It can be easily disassembled. And that shifting in thought will be really impactful in terms of timescale. Implementing that thought is a bit more challenging because now what we're doing is we're forcing ourselves to really think about what happens to this product when people are done using it. A lot of industries, I would say, are probably slow to adapt. And I'll hopefully, if I have time to talk about it, I will. But I will say, most industries really try to promote what I call a throwaway culture because it's more economically advantageous for them. For us to throw things away, right? Why? There was a joke about I think I used the Maytag man before as an example, but I'll use a comedian's joke because I think this one is more prescient. He was talking about the polio vaccine and how that there was no profit from the polio vaccine, right? So the big joke was that there's a lot more money in the treatment than in the cure. And right, and if we are telling companies that the cure is for us to not buy as much of their products, right, a company will say, you are crazy. What are you talking about? Our bottom line is to sell as much cups as possible. So we have to figure out a way for really bridging that divide amongst mindsets. So let's say we happen to get through all the red tape and are able to finally do recycling of products, at high throughput. Other challenges can and do come up. So here we're kind of looking at a figure of a polypropylene part. I'm using a car bumper here just so that we can visualize, just some of the ramifications of a recycled product. So if we just look at these three bars, or three sets of bars in the center of this figure, we can see that when we reproduce the same part from recycled material or from a mixture of recycled material, modified recycled material, plus virgin material, we see that there is comparable performance. But when we look at MFI, which is just a melt flow index, what should stand out to us is that this figure is telling us that we have to put a little more effort or energy into reprocessing this material as we would a virgin material. But then also, certain mechanical characteristics of the recycled parts are detrimentally reduced. So this notched impact strength here is just to kind of explain what it is. Certain materials, if you put like a little tear in it and then try to really rip it apart, certain materials can withstand that, others can't. And what this is telling us is that, heaven forbid, if we try to put this in a bumper, if there's a slight nick in our bumper and then we hit our bumper again, catastrophic failure of our part, right? And that is where some of the hesitancy kind of comes up on the industrial side on what to do with recycled material. So I kind of analogize this to a comparison between Superman and Bizarro. So I call it the Superman versus Bizarro analogy. If you don't know who Bizarro is, that's perfectly fine. So if we kind of think of our desired product as Superman, right? It performs the way we want it to perform. It does everything that we want it to do. And then we say, well, we're going to recycle this material because we know we're going to recreate Superman again. What sometimes happens is that we actually create Bizarro, right? So if we use the figure that I was just talking about, is that we think that we're going to have all the same properties, but in fact, our properties change. And that is where a lot of the hesitancy in industry comes along, especially if we're recycling from a mixed stream waste, for example, where there's potential contaminants or other materials in there. We end up with Bizarro, and then we're stuck with Bizarro, right? So the shifting mindsets, at least industrially, is that we shouldn't expect to recreate Superman all the time, right? So what we've been trying to adapt is essentially creating new products from some of these recycled materials that we recognize that we can't get back to the original properties in that native material. So we usually call that downcycling if there's a knockdown in the properties, upcycling if the properties are enhanced. But something that doesn't get mentioned as much as the plastics waste issue that I always try to remind people of is that plastics never normally are what I call homogeneous materials or monolithic materials, right? They're normally blended with other things. In fact, all these other things or these additives that they're blended with actually helps to promote the processing and the utilization of that plastic itself. To the point where the additives market is a multi-billion-dollar market, and in terms of oversight, probably not as much oversight as there needs to be. Usually, the oversight often happens reactively when there's some inadvertent ecological consequence or physiological consequence. And the example that I always talk about is BPA, bisphenol A. So bisphenol A was a really common additive in plastic products, maybe up until the late 90s, early 2000s. But it was found that the additive BPA would actually leak out of materials and cause a range of physiological disruptions to us human beings. So now, when you go to, buy certain products, you would see BPA free on the side effects, right? But what you should always ask yourself as a true sustainability ambassador is, well, you removed BPA, but did you substitute BPA for? Is it just as consequential in terms of the human effects? What data do you have to support that? And things like that, right? Because as you can see, most commodity plastics would not exist without the addition of stabilizers. So in terms of a brief history on the polymer waste issue, luckily, unluckily, unfortunately, depending on your perspective, this problem has been known for a long time. In fact, it's been known for over half a century. So it's not anything new. In fact, it was first suggested in the 60s that the non-biodegradability of certain polymers, or I should say non-degradability in our lifetime of certain polymers, would present a problem, right? Because in the 1960s, there was a great championing for the broader use of plastics, which means our consumption of plastics increased, but our attitudes towards the waste product did not get increased, right? In fact, our attitudes have been more or less the same, even though a long time ago someone said, hey, you better watch out for that problem, because if you don't deal with that problem now, it will become a big problem. To the point where campaigners in that time predicted that, at the end of the century, which has come, that the planet would be covered by a layer of non-degraded plastics. And one can argue that, we're probably not at that point where, every square inch is covered in plastic, at least plastic waste. But that size is growing, right? To the point where we have a sea filled with plastic. At least a part of the Indian Ocean has formed a sea of plastic that is not going anywhere anytime soon. We have plastic waste buried in the ground that's not going to go anywhere anytime soon. Yet our consumption of plastic is increasing, right? So really, what do we do? So it got to a point where in the 80s, the packaging industry specifically was challenged by legislators or lawmakers to start recycling their products or else, right? That's normally what they say to industry, and industry says, okay, sure, fine. But what they quickly recognized, like I said before, that recycling was not as straightforward as they thought it would have been, because I'm sure that they thought that they were going to get back Superman, and instead they kept getting Bizarro, right? So what essentially happened was essentially a disinvestment in the recycling industry, right? If we kind of look around the world, or even look in America, there's no subsidies for recycling, almost at all, right? There's nobody saying, hey, I will put up 10 million bucks just to make sure that recycling, sticks around. Not much of that. But when we think about waste and waste management, we're really just trying to protect ourselves, right? That's really what it is, right? We're trying to protect people, and we're trying to protect the environment, right? We're trying to protect our home. So it's very, very important that we take waste management seriously, right? It needs economic investment. But if you do just a quick search on, just investing in waste management, people oftentimes look at it as a dirty job, right? It is a dirty job, but it is an essential dirty job, probably the most important dirty job ever. But when we think about, disposing of waste, right, we ideally want to be able to reclaim waste, right, in terms of sustainability. And we want to minimize waste that we actually put into the ground. But if you notice, I've just talked about waste management and what we do with the waste. But just as a political discourse or philosophical discourse, the only thing I will say is, what about resource management? How are we managing resources? And I will, I will say as just as a civilian of Earth, we are not doing a great job at managing our resources. In fact, our attitude towards resources is extract, 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 extract. When we run out, find somewhere else, extract, 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 extract. To the point where some of the most resource-rich nations in the world are actually some of the poorest nations in the world, which really doesn't make sense. But I'm not a politician, nor am I an economist. So when it comes to resource and waste management, right, what we try to follow, or what we've been trying to adopt as a global body, is what we call the hierarchy of waste management, right? So we try to reduce our consumption, reuse as much as possible. If we can't reuse, can we recycle for some other application? If we can't do either of these three, then fine, let's incinerate, let's burn this thing. And last but not least, right, because of what I call the need for space for a growing population, putting things in the ground is often a last resort, especially putting things in the ground that are not degraded nor inert to the earth, right? Because there can be potential ecological consequences as well. So when it comes to following the trail now, to really understand the process of waste and resources and how they're connected, what we start to generate are what people call life cycle analyses. There's other terminologies that they go by, but what I like to call it, I just like to call it following the trail, right? Because it sounds a bit, it sounds very practical in that way, where we essentially follow our resource all the way through processing, all the way till it gets into the land, right? So we understand and really appreciate just how interconnected industry is when it comes to bringing a product to market, right? So we take our resource, be it oil, be it bioproducts, be it forestry products, be it mining products. We send it through a refining process. For plastics, we make our monomers, we polymerize it, and then finally, it gets to us as the consumer, right? So what this diagram tells us is that us consumers, we are a part of this process. But what's not spoken of a lot is that this step here, even though it's one step in many, this is actually the bottleneck in the process, because we essentially are the rate limiting step in the process to any of us who does chemistry or any engineering, right? But that just means if we don't consume as much, right, then we don't deplete as much resources, or if we reuse as much, right? If we start practicing reusing and recycling items, right? So it's really us as a body politic that controls this entire process. And what I've come to realize is that we are slowly galvanizing as a body politic in recognizing our importance in this process, because right, it's really all for us, right? We are the consumers, right? So we should recognize that we have a lot more control over this process. So what's been emerging fairly recently, at least on the economic side of things, is what we call the circular economy, where a lot of financial institutions are trying to figure out ways to financially incentivize recycling. This is fairly new, I will say. This is fairly new, maybe within the last 5 to 10 years. And in terms of results of adopting notions in circular economy, right now there isn't much data yet, right? Because what I know is that right now, at least from a national agenda standpoint, there is no national agenda on recycling. There is no national agenda on reducing consumption, right? So really what often happens is the can gets kicked down to the consumer, right? So it's actually very admirable right now to see financial institutions trying to help to find ways of making this process financially attractive, is what I should say. So in terms of the conversation we should be having around sustainability, what we should recognize is that, sustainability means different things to different people, yes, but for what we are trying to talk about, what we should recognize is that we need concepts and notions of the environment, concepts and notions on economics, and concepts and notions and habits and practices of society to really all converge in the sweet spot of sustainability, right? For us to recognize that, we are humans, we are consuming, we have a financial system that essentially champions consumption. So there's a lot of things that have to come together for us to truly deal with this problem of sustainability, for us to really come together and start working towards tangible solutions. So, this is where what I call the innovators and the dreamers come in, right? So, if we think about an answer, right, this is one of my favorite fictional characters of all time. If you don't know him, his name is Wayne Szalinski from Honey, I Shrunk the Kids. So, the question I kind of put out in whimsical fashion, but really as a philosophical sense is, would we really benefit from the mind of Wayne Szalinski, right? Would we benefit from an invention that allows us to just shrink and essentially make our waste disappear, right? Or like put it on really, really, really tiny scale? Would that? I'm sure that would make for a really interesting, debatable topic, but one can argue that it probably wouldn't help as much as we think it would, because really, this is dealing with the waste issue, right? It doesn't help with our resource dependency as well, right? So, but it's really, what I'm really trying to say is, we really have to start challenging ourselves to think innovatively about the systems issue of dealing with resource management and waste management. So what usually comes as a surprise is that in terms of dealing with waste, incinerating it, oddly enough, is actually one of the better approaches. If I said this 40, 50 years ago, I'd probably be chased out of the room. But technologically, we can actually, what I like to say, we can actually scrub a lot of the environmental pollutants out of the gaseous products so that nothing harmful gets released to the environment. A lot of countries actually practice incineration for energy. In fact, I would say a large number of countries actually rely on this as their primary form of heat production and energy production in the world. But in terms of attractiveness, there's still a lot of hesitation with just broad scale implementation of incinerating, and rightfully so, right? We're burning products. Who decides what neighborhoods these incinerators are in, and so on and so forth, right? So when it comes to dealing with the challenges, right? So the first thing I would have to say is we have to deal with the societal challenges, right? As human beings, oftentimes we have a hard time looking at ourselves objectively in terms of our role or contributions to what goes on planetarily. But I think we are getting to a point where if we don't reconcile our presence on Earth, there will be dire consequences. And we can kind of see that popping up in small pockets. And if all the predictors are right, we have less than 30 years to figure things out. And by then I'll be an old man. But hopefully we go in a different direction. Also, we have to recognize that throwaway culture is pervasive. I can't tell the last time I saw a place where you could get things fixed beyond an Apple store, right? Anywhere else, you're oftentimes encouraged to just throw it away and buy something new, right? So what I'm saying is we are encouraged to throwing things away inherently. And there are a range of market forces that push us in that direction, right? And as a consumer, once we start recognizing our collective voice, we're going to have to say, hey, we probably shouldn't be, so quick to throwing things away, right? We should try to find another way of dealing with the thought of, just throwing it away and buying a new one. And then there are economic challenges, right? Usually when it comes to economics, the real driver for economics are supply and demand, right? So in this wonderful cartoon here, this guy wishes he had a rock. Look, there's a guy with a rock. This guy wishes he had a stick. Look, there's a guy with a stick. Look, we can trade, right? I give you my stick, you give me your rock. one of the challenges with recycling is that there isn't really a market for recycled products, right? It's really difficult to compete with virgin material because the oil industry is heavily subsidized, right? So they get paid a lot of money to make these materials for cheap. And when you make a recycled product, you have to invest all this time and effort into recycling this product, and then you can't essentially compete, at least on an economic level, with the virgin material, right? So that's a big economic challenge. And oftentimes, what would usually happen, right? Even though we have very altruistic goals in terms of recycling, it's usually the art community who embraces recycling a lot more because they're very creative people. They can do with any sort of material. But for practical purposes, we're going to have to think way beyond the art community in terms of how we recycle efficiently and effectively to essentially be cost competitive with the oil industry or with the subsidized industries, I should say. Right? And the easiest argument would be, well, why not just subsidize the recycling industry? Easier said, but we'd probably need a range of lobbying efforts to just get someone to even pay attention to that statement. So then, we're kind of left with the final economic challenge, right? So who do we hold accountable? How do we hold them accountable? And to me, I would say that this is probably one of the bigger challenges because we have what I call the out of sight, out of mind mentality. The moment all this garbage leaves us, it's not our responsibility anymore. To the point where I think I saw a few lawsuits going up against Coca-Cola. While I think those lawsuits are admirable, I hope it at least brings some attention to the lack of accountability in the waste issue. But if I'm going to be realistic, I'm not sure if Coca-Cola is the person we should be pointing the finger at, right? But again, I'm not a lawyer, I'm not an economist, not a politician. Just a civilian trying to make sense of this problem. But really the biggest issue that hopefully we all should appreciate is that, we have only one Earth. I know there's a lot of talk now, especially from SpaceX and NASA about, going to Mars, colonizing the moon, finding habitable planets. But really, I love the smell of fresh air. I love swimming in the ocean. I love swimming in whatever body of water I can find. I love walking around barefoot whatever chance I get. You can't do that in Mars. You can't do that wherever we colonize. And even if we find a habitable planet, it's light years away, right? So I will never get to enjoy the splendor of some habitable planets light years away, right? We won't get to enjoy that. In fact, it would probably take us 10 generations just to get to that habitable planet. So my argument is always, why aren't we focusing more on our planet and what we're doing to our planet? And to me, that's a big environmental challenge that I think a lot of industries really try to pass the buck on. And as the consumer, we're often left holding the bag, right? And we really should try to figure out a way of turning that back onto industry and legislators to say, hey, we care about our planet. These are our demands. Okay, a few more slides, and then I'll be done. So another answer that's often championed is, well, let's just make all materials biodegradable. If it's biodegradable, then we don't have to worry about overuse of land resources, issues in recyclability gets overcome, because we will just leave these materials to Earth to deal with. And again, it's not as straightforward as it may seem. In fact, I use this example of a sequoia tree that had fallen who knows how long ago. I think it fell like in the 1920s or early 1900s. Fallen tree is still there, right? And yes, a sequoia tree is biodegradable, but what we always have to talk about is bioassimilation, right? So how long does something take to actually get reassimilated back into the environment is a big issue. And believe it or not, in principle, all polymers, if that polymer can be oxidized or if it can be hydrolyzed, which is almost all polymers, then they should be ultimately biodegradable. But it's oftentimes, is it biodegradable in my lifetime? Is it biodegradable in my children's lifetime, in their children's lifetime? How long do we actually have to wait for this tiny cup to go away? And that is usually one of the misconceptions in biodegradability. In fact, there's this what I call notion of greenwashing going around. I don't like saying the term greenwashing, but it's essentially being very mindful of notions in biodegradability and what I call eco-friendliness. So in terms of the green criteria, right, really, if any company wants to classify themselves as green, right, that they essentially have to have some degradable plastic, right? In principle, many plastics are already recyclable, which is something I said earlier, but if there is no market for it, or if there's no technology to essentially demonstrate that this material is recyclable, then what's the point, right? We have to essentially, again, adopt a systems-based approach. And then, in terms of bioassimilation, right, there could be long-term effects of man-made materials, right? It might not impact us in our lifetimes, but if 100 years from now, this tiny cup starts leaching out death juice, then that's a problem, right? So we really have to understand lifetime consequences in fulfilling some of these green criteria. And usually, the notion of biodegradability and concepts in eco-friendliness often causes misconceptions to the point where I see a lot of companies say, oh, this thing is biodegradable, that thing is biodegradable. Oh, this is so amazing. But sometimes, these misconceptions actually exacerbate some of the pollution problems, right? So for example, if a company is advertising that some material is biodegradable, we would really benefit from knowing how biodegradable it is, right? And how long do we have to wait for it to biodegrade? Because normally, if companies make a product to be biodegradable, ideally they want that product to last the lifetime of however long you own it, right? So there is some time scale for biodegradability or degradability that we always have to consider. When it comes to existing waste management systems, if we make a biodegradable or degradable material that cannot find a way in our infrastructure, then even if it's biodegradable or degradable, if we don't have a mechanism to degrade it, at least industrially, then we've essentially created problems for ourselves, right? Because now we're just going to have this material accumulate as waste. In terms of the effects of biodegradable materials on the environment, right? We shouldn't assume that if this material is biodegradable, that it's safe for the environment, right? We always have to really question that. If it degrades, are the degradation products safe for the environment? And that's something that we always need to do as environmental stewards. And then really, talking about its degradability. How does it degrade? What do we have to do to degrade this material, right? Because not because it's degradable doesn't mean that it will just degrade by sitting on top of my desk all day. No. Sometimes we have to program the degradability, right? Sometimes I have to heat this up, I'll put it in an ice bucket, do something to it for it to start to degrade. So hopefully what you realize is that, the term biodegradation is somewhat broad, could be somewhat ambiguous, and we always have to be really fervent in just saying, tell me what you mean by biodegradability or degradability. What exactly do you mean by that? And a lot of times you'll realize that the person who is championing that can't even tell you. Okay, finished with 5 minutes to spare. So just to conclude, when it comes to sustainability, in the context that we often try to talk about it in, usually what we're talking about is resource and waste management, right? Ensuring that we're effectively managing these and pushing them towards these concepts in circularity, and especially in ecological sustainability, right? Because like I said, we only have one Earth, right? And as far as I know, I can't live on Mars, I can't live on Venus, and I'm not interested in trying to find planet X313 anytime soon. And when we think about recycling, we have to really start thinking about innovative ways, especially in improving the energy economy, efficiency, and utilization of recycled products, because it's not just enough to say, okay, we're going to recycle this material. We have to build a market for this recycled material. We have to ensure that there's some incentive for this industry to thrive, and right now there isn't. We need to find new and renewable sources of energy, right? There is a finiteness to our resources. So we really just have to be champions in really always pushing the envelope on what are we harnessing energy from and how reusable and renewable is that resource. In terms of product design, we have to really change our ways of designing products, right? So we have to essentially integrate durability for lifetime of usage and also degradability for easy disassembling of this material or this product so that we can effectively recycle it. And then last but certainly not least, recycling would greatly benefit from incentives. I'm not sure why there isn't any, why there isn't a national agenda for recycling or even sustainability. I'm sure a few presidents from now that might end up being a national agenda if we especially keep pushing the button. But really, we have to really sustain being champions of this cause. And that takes us to the end. Thank you very much for listening. I know we are close to the end, but I would be happy to have some questions and engage in a discussion. And oh, you are looking at a chemical reaction right now, so let me remove that. Okay. So that was the end. I conclude.
Thank you very much, Dr. McKenzie. If anyone has any questions, feel free to unmute yourself, or if you feel more comfortable, you can type it in the chat and I can read them. But if not, have a great spring break, and hopefully we will see you at the education team spotlight that will be starting here shortly.
Thank you, Dr. McKenzie. I have to head over to my spotlight night, and the link is in the chat if anybody wants to hop over. So thank you.
Thank you, Dr. McKenzie.
You're muted, Dr. McKenzie.
I'm muted. Sorry. I was yapping and not recognizing I was muted. I was just saying all the best in your presentation, Megan, but she's gone. And you are welcome to whoever said thank you. And I wish you all a wonderful rest of your evening.